All right, let's dive right into this explainer and totally level up your knowledge about our home planet. Today, we're going to move step by step from the absolute basic facts right up to some seriously top-tier planetary science. So whether you're cramming for an assignment or just, deeply curious about the giant rock we're all standing on, this guide is going to put all that essential data right at your fingertips.
Because honestly, if you want top marks for your next project or if you just want to be the smartest person in the room, you really need to know exactly what makes our little piece of cosmic real estate so uniquely special. We're going to build a complete layered profile of Earth today, mixing basic metrics with some pretty advanced scientific concepts.
Section 1. Our place in space. Let's start by establishing the absolute foundational requirements of our cosmic address.
So, the crucial thing to remember here is that our exact position in the solar system really sets the stage for everything else we're going to uncover today. We are officially the third planet outward from the Sun, sitting squarely in the orbital space right between our planetary next-door neighbors, Venus and Mars. This specific placement is literally the very first thing you need to lock down when describing Earth's location.
And actually, our name perfectly illustrates a super fun anomaly. Think about the other planets in our solar system for a second. They all take their names from Greek or Roman gods, right? Jupiter, Mars, Venus. But our planet? Entirely different. The name Earth actually comes from ancient Germanic and Old English words that just mean ground or soil. It's kind of wild, but we are the only planet not named after a deity. We just chose to honor the literal dirt we stand on every single day.
Moving on to Section 2, Earth by the numbers. Let's hit some rapid-fire stats to satisfy those baseline assignment requirements.
If you look up into the night sky, the count is incredibly simple. We've got exactly one moon keeping us company in orbit, just one single, natural satellite tethered to us as we hurtle through space.
Next up is the sheer, mind-boggling size of our world. If you were to draw a line straight through the center of our planet, like all the way from one side to the exact opposite, it spans a massive diameter of 12,756 kilometers. That giant measurement gives you a real sense of the physical scale of this rocky sphere we call home.
Now, remember that third planet position we talked about a minute ago? Let's put a precise number on that. We maintain a vast, and I mean absolutely vast, distance of 149.6 million kilometers away from the Sun. That massive spatial gap is the exact bridge between us and our home star. And, because of that crazy distance, our journey around the Sun takes a very specific amount of time. It takes us precisely 365.2 days to complete one full orbital year around our star. And that tiny little fraction, that 0.2 at the end, that dictates the rhythm of our entire calendar system. It's exactly why we have leap years.
All right, Section 3, Composition and Surface Conditions. What's really interesting here is how we transition from these abstract numbers to our tangible, everyday, physical reality.
We can basically break Earth's composition down into three defining features. First off, Earth is classified as a terrestrial or rocky planet. Second, resting right on top of that rocky crust, we've got a surface ocean made entirely of liquid water. And third, wrapping around all of that like a giant invisible blanket is an atmosphere containing a very specific, vital blend of gases, most notably oxygen and methane. This exact combo of rock, liquid water, and mixed atmosphere, that is the unique chemical signature of our planet.
And because of that unique composition, our surface conditions settle into a remarkably stable baseline. Earth boasts a mean global temperature of 15 degrees Celsius. Plus, our atmospheric weight creates a standard surface pressure of exactly 1 bar. These two precise physical traits, 15 degrees Celsius and 1 bar of pressure, they provide the fundamental environmental conditions that cover the entire globe.
Okay, Section 4, Advanced Planetary Science. Let's see how all of this builds into our masterclass tier. This is where we unlock those advanced concepts that are absolutely going to impress your teacher.
So, Earth is currently the only planet we know of that supports a true biosphere. And a biosphere is essentially a global ecological system. What makes this so profound is that life hasn't just existed on Earth, it has co-evolved with the planet's physical environment over billions of years. Our living organisms in physical environments are deeply structurally intertwined. It's like a giant puzzle where all the pieces slowly adapted to fit each other perfectly.
But to really grasp how long this interconnected biosphere took to develop, we have to look way back into deep time. We're talking an astounding 2.5 billion years into our planet's history.
So why is that 2.5 billion year mark such a big deal? Well, that is the immense amount of time required for early photosynthetic organisms to evolve. And once they did, these microscopic life forms completely changed the game by aggressively pumping oxygen into our atmosphere. It was literally their biological activity that created the modern, breathable air we rely on to survive today. The biosphere actually shaped the atmosphere itself. How cool is that?
Which brings us to what is probably the most advanced and definitely the most fascinating concept on our list today: thermodynamic disequilibrium. Basically, Earth uses constant energy flows, specifically solar energy from the sun, and geothermal energy bubbling up from the Earth's core to maintain this state. In simple terms, the planet maintains a highly complex active chemical imbalance, and this specific, continuous state of energy flow and imbalance is an absolute primary requirement for sustaining life. And you know what? All of this incredible science, the 149.6 million kilometer distance, the surface oceans, the 15-degree mean temperature, the billions of years of biosphere evolution, and the complex thermodynamic disequilibrium, it is all wrapped up in a single, elegant astronomical symbol, a circle with a cross inside of it. That right there is the official universal shorthand for planet Earth.
As we wrap up this explainer and you get ready to absolutely crush your assignment, I want you to consider one final thing. When you think about the vastness of space, the insanely strict physical conditions, the billions of years of coevolution, and the constant energy needed just to maintain thermodynamic disequilibrium, I want to leave you wondering just how rare this fragile, life-sustaining balance truly is in the vastness of the cosmos. Keep that question in the back of your mind and keep exploring.